Welcome back, student. Hopefully by now you have the chance to solve this problem all by yourself. Now I'm going to show you the solution step by step. So the enthalpy changes for this reaction is equal to negative 860 kilojoule per mole. That is very important because now we can use this as a conversion factor in later unit and how we can actually convert mole of each of the substance here using these conversion factors, okay? But we save that for now. Now we are going to look for, in this case, the formation of aluminum oxide based on the information. So when we solve for this, before we learn how to find the changes of the reaction. Now we are looking for the formation of a specific substance. So reaction versus a substance, that's the big difference. Now, in most cases, the textbook will have the values of each of the substance involved in a chemical reaction, but in this case, it's a test, so it's not going to give to you. It's going to give you limited information. So let's go in and solve it. So delta H of reaction, or delta G of reaction, delta S as well, is always the sum of the product minus the sum of the reactant. And we know that any substances that are elemental is equal to 0. So what we can do here, we can find all the one that has an element by itself equal to 0. So we can simplify our math, right? So let's plug it in. Now if the reaction is negative A60, a product, this is on this side, we just have aluminum oxide left. We don't know what it is, right? But for now, we know that has to be a 1 because there's nothing there. So it's parentheses 1, so 1x, okay? On the reactant side, we have this, again, it's just 1. We have to use the coefficient. But we also know the values of iron oxide, which is right here. So we know it's 1 times negative A16, which is equal to negative A16. So we have this minus and minus, that become a plus right there. Isn't that easy? So how do you solve for x? Well, that's pretty easy. All you have to do is, look at this. We just minus A16. See how this cancel out? If we do to that side, we also have to do to this side as well. So this cancel out equal to 0. So what is x going to be? So now we plug into our calculator, give you, we have negative A60 minus A16, give you negative 1676. There you go. So right here, well, in this case right here, we can tell this is 0, this is 0. And right here is negative 1676 kilojoule per mole. And this reaction is considered exothermic. And don't get tricked, okay? We are looking at the values of the reaction, which is right here. It's exothermic, okay? And therefore, it's going to release heat or release energy to the environment. So don't get tricked, okay? In some case, your answer here is positive, but up here is negative. So we have to look at the reaction, not the individual formation of the substance. And that's how you apply your understanding in a different perspective to solve this particular problem. And if you have any question, please let me know. And we'll see you next time on another exciting chemistry video.